So what we're going to work through today is Lab 13, which is titled Locating an Epicenter. And before you get going, you want to make sure you have a paper copy of this. So as we go through this, you'll be filling out and collecting data and working through some problems, and you'll want a paper copy to write your answers down on. So the purpose of this activity is to locate an epicenter. And an epicenter has to do with earthquakes, and earthquakes have to do with earth science. And the idea behind earthquakes is it's all down to the interior of the earth. So if you didn't know this, Earth's interior is hot. The deeper you go, the hotter you get. And that heat, that energy, wants to expand. It wants to rise to the surface. This is a process called convection. And as that energy is trying to escape and move out from the Earth's interior, we have a partially molten layer of the Earth called the asthenosphere. It's squishable. It's a plastic layer. Plastic just means it's flexible. And on top of the asthenosphere is the lithosphere. The lithosphere is the rigid continental plates, and rigid means that it is not flexible. So all of this, in summary, means that the Earth's surface has a rigid layer called the lithosphere that we live on. You're standing on it right now. And below that is the asthenosphere, which is a squishable layer. And then there's this interior heat pressing on the surface, trying to get out. And what that does is it creates a force, and it literally moves the Earth's surface. So this is the idea of plate tectonics. So the Earth's surface is broken into pieces that move and interact due to unequal heating of the Earth's interior. And the Earth's surface is rigid. That lithosphere is rigid. It doesn't move nicely. It doesn't move smoothly. A lot of times those plates get caught up and they don't glide nice and smooth past each other. They kind of stick, and you get pressure buildup. And when that pressure is too much, you get an earthquake. Earthquake is just a release of that energy, that interior energy at the Earth's surface. And so what we're going to work on is an epicenter. And an epicenter has to do with these earthquakes. So when there is an earthquake, energy radiates out in all directions. And when it reaches the Earth's surface, the point of the most destruction, or the center of that destruction, is called the epicenter. And we want to find the epicenter as soon as possible. The epicenter is where the most damage is. It's where we need to get help, emergency services to people. So scientists want to find the epicenter as soon as possible. Sometimes it's kind of tricky. Like, for example, this earthquake that we're going to work on, this is the 2004 Indian Ocean earthquake. This was actually an earthquake that occurred on the Indian Ocean floor. So a lot of students have a misconception that earthquakes only occur on dry land. It doesn't. There's the ocean floor. You can have earthquakes occurring on the ocean floor. You can have it occurring on continental crust. So an earthquake can and do happen on the ocean floor. And when that happens, that energy is released into the ocean water itself, and it generates what's called a tsunami. So if you've never heard the word tsunami before, this 2004 Indian Ocean earthquake generated a devastating tsunami. This was a wall of water that was upwards of 100 feet high. We lost almost a little bit over 250,000 people from this Indian Ocean earthquake. And the idea with this activity is we're going to show you how scientists would find the epicenter. And this one happens to be on the ocean floor, but if it's on land, the process stays the same. In order to do this, you'll want to have a paper copy, as I said before, and we're going to follow the procedure that's listed towards the bottom of this. Okay, so if you could follow along with me. So the procedure to find the epicenter, and again, the point of this is to find the epicenter as soon as possible so scientists can alert people where the greatest danger is, where the most damage from that earthquake is. So step number 1, use the provided seismogram, determine the exact arrival time of the P wave in hours, minutes, and seconds, and record this measurement on the following chart. Okay, there's a lot to unpack in this statement. Using the provided seismogram. A seismogram is a paper record of an earthquake. Earthquakes travel in waves, and we can record those waves. It kind of looks like a heart monitor or a lie detector test, if you've ever seen that on a TV show. So earthquakes, the energy travels in waves, and we can calculate that. So in this packet, you're given seismograms. So if you flip your page over and you go to, this is 73 in your lab manual, you have 3 seismograms that you're given. So I'm going to focus in on seismogram number 1 here. So this is a seismogram. This is a record of that earthquake. This one was collected in China. So seismograms don't have to be collected at the epicenter. They can be collected anywhere. Seismic waves travel anywhere along the Earth's surface. And this record happens to be in China. So the epicenter is not in China. It's just that they felt the earthquake there. So seismograms give you 2 things. So if you look on the 2 axes here, so first it gives you the amplitude. Amplitude is a fancy way of talking about the size or the amount of energy that's there. So where it says 0, there's no energy. Once it starts to squiggle and jump, it means that the ground is literally moving, and those squiggles are the release of that energy. The top axis is the time axis. So this is recording on December 25th, 2004, and it gives you the hour, the minute, and the second. So the way you read this is 010300. So this is military time. This occurred at 01, that's the hour, 03 is the minute, and 00 is the second. So this is 1:03 a.m. Okay, so we have 103, 104, 105, 106, 107, so on and so forth. Okay, so you have seismogram that gives you the amplitude, and it gives you the time for these things. Now, what were we supposed to do? So step 1 says, using the provided seismogram, determine the exact arrival time of the P wave. Record this measurement on the following chart. Okay, so we got to figure out what a P wave is. Now, earthquakes travel in waves. So here's our seismogram. This is the same one from China. It starts out, there is no energy, so the earthquake hasn't really started yet. And at this point right here, where the line starts to squiggle, this is where the ground literally is starting to move. And I've marked on here where the P wave is hitting. So when an earthquake hits, there's generally 3 waves that will hit a location. The first wave is called a P wave. P stands for primary wave. Primary wave is a longitudinal wave. It means it travels in a front to back, push-pull type of a motion. P waves are very fast, but they're also pretty small in amplitude. So if you look, the squiggles, they're not that big. So the movement isn't that traumatic. As we look along, we see more. So when an earthquake happens, there are multiple waves hitting at the same time. Now these can be aftershocks, these can be additional P waves, but there is a second wave that hits, and I put a little line on here to mark it for you. So this one is the S wave. So S stands for secondary. And this is the second, where the name comes from, secondary, second wave to come at you. And this is a side-to-side motion. So this is more of an S, like a snake type of a movement. As you can see, after the S wave hits, the waves, the amplitude starts to get stronger. So there's more movement with it. So in an earthquake, when an earthquake actually hits, there's 3 waves. The P wave hits first, the S wave hits, and then later on, it's called the surface wave. Now, we're not giving you the surface wave. It's not that it's not important. You just don't really need it to find this, to find the epicenter of this thing. All you need to find the epicenter is a P wave and an S wave. Now, on a normal seismogram, these would not be labeled for you because this is a 100 level class. I'm giving it to you. So the P wave is hitting here, the S wave is hitting here. If you look at your other seismograms, so this one is from, so it's abbreviated KMBO. This is from somewhere in Kenya, you'll see in a second. You'll see this one has a block, that's your P wave, and then later on is an S wave. Notice the times aren't the same as when in China, so different locations are going to register a different time. We had a third seismogram. This is GUMO, or the island of Guam. Again, same thing. This place recorded the earthquake, but different P and S waves. So this is the same earthquake, it's just recorded at 3 different locations, okay? Again, P wave comes first. It's the fastest, but it's the least destructive. Then your S wave comes. S wave is a little more powerful, a little higher amplitude. Later on, you would see on this seismogram the surface wave, which is the most powerful, but for this application, we don't need it. Okay, let's go back to the top here. So it says on my directions that I need to use the provided seismogram, determine the exact arrival time of the P wave in hours, minutes, and seconds, and record this measurement on the following chart. Okay, I think we got this. So we've got our China seismogram here. It's asking for when did the P wave arrive? So when did this thing hit? Okay, so we got to figure out the hour, the minute, and the second for when this thing hit. Well, we know it hit, the hour is 1 o'clock. So we know it's between 1 and 1, so we know it's 1 o'clock. The minutes is the second unit here. We know it happened 4 minutes. The hard part is trying to figure out, well, how many seconds is this? So the dark line is the 0 seconds, and then there's these little smaller tick marks in between before you get to the next bold one. So this is 60 seconds, this is 60 seconds. We need to figure out, well, how many seconds are these little tick marks? Okay, I see 1, 2, 3, 4, 5. There's kind of 6 spaces in here. So that tells me each one of these is 10 seconds. So if this is 104 and 10 seconds, 104, 20 seconds, 104, 30 seconds, okay? Well, let's keep going just to make sure we're right here. So this is 30 seconds. This next tick would be 40 seconds. This one would be 50 seconds. And this is 60. So we're right. Each of these little tick marks is 10 seconds. Okay, cool. So we think the P wave hit China at 010430. And it says in the instructions that we're supposed to put this in some sort of data chart. Okay, well, we got to find a data chart here. Let's see. Data chart.